So we're on to the sixth video, the statistics of risk. That's specifically relative risk and attributable risk. You'll find these very often in biomedical studies. So make that comparison. No. There's attributable risk, which is the probability of the outcome in the exposure group minus the probability of the exposure in the control group. And this formulation means a couple important things. If the number is positive, exposure increases the risk of the outcome. And if it's negative, exposure decreases the risk of the outcome. What that means is, like if you're looking at the relative risk of smoking on cancer, then you're going to have, sorry, not the relative risk, the attributable risk. The attributable risk of smoking on cancer, you're going to have a positive number because that's going to increase. But if you're looking at the risk of aortic rupture with being compliant with hypertensive medication, then that number is going to be negative. Your risk is going to be decreased by exposure to antihypertensive medications. And when they throw up confidence intervals, if it straddles 0, that means it's statistically insignificant. But if the confidence interval is either above 0 or below 0, that means it is statistically significant to that confidence interval, because that kind of makes sense. That means if it's straddling 0, that means the actual risk is either increases or decreases exposure. Statistically, you're incapable of saying based on the data you have. So, but if it's otherwise, the confidence interval is completely on one side or the other of 0, then it's statistically saying, yes, this is, we're 95% confident that there is an increased risk or decreased risk. I hope that all makes sense. Relative risk, on the other hand, is the probability of the outcome in the exposure group divided by the probability of the outcome in the control group. So that means instead of 0 being the null state, 1 is the null state. It's when something divided by itself always equals 1. So greater than 1, exposure increases risk of outcome. Between 0 and 1, exposure decreases the risk of outcome. And once again, the confidence interval works the same, except you're looking to see if it straddles 1. And if it straddles 1, it's statistically insignificant. And otherwise, it's statistically significant. I hope all that makes sense. All right. I'm going to use these in a couple concrete examples. These are statistics from about 10, 15 years ago. So they might have been updated, but they're good enough for right now. So remember, attributable risk is the probability of exposure, probability of the outcome of the exposure group versus the probability in the control group. So probability of injury due to auto collision in the general US population is 0.0008 per year. And the probability of injury due to auto collision when blood alcohol is greater than 200 is 0.024 per year. So you do the math and you get an attributable risk of 0.0232. So what this is saying is driving with a blood alcohol concentration greater than 200 increases your attributable risk of injury due to auto accident by 2.32%, which kind of sounds like a low number. It's not a low number, mostly because Americans drive everywhere. We're a very automobile-centric culture, so that means the amount that we drive coupled with that increased risk means that there's a very high likelihood that you are going to suffer an injury if you are driving drunk. Not 100%, but from a public health standpoint, it's actually a really good target to try to get return on investment in terms of reducing mortality and morbidity. But the problem is that when normal human beings look at 2.32%, it doesn't seem like a big number. So it's kind of very easy to brush it off. Let's compare that to relative risk. Same inputs. We're taking the same, data, but now we're taking 0.024 and dividing it by 0.00008. And now you get a relative risk of 30. So the same data, regularly driving with a blood alcohol concentration greater than 200 increases your relative risk of injury due to auto accident by 30 times. And now suddenly that sounds like, oh my gosh, like this is a really big deal. And the point I'm making here is it's exactly the same data, but it's packaged differently. And one seems far more impressive a statistic than the other, even though the underlying data is precisely the same. So important when you are assessing risk as presented by a biomedical study, you have to be careful because relative risk has inflationary effects that may inadvertently be misleading. But on the other hand, attributable risk may downplay controllable factors that we can target to improve health in populations. Here, of course, is Archimedes pictured having his eureka moment. So let's give this a whirl. This is from a study from about 10, 15 years ago, and it's looking at different predictors of abdominal injury in trauma cases, and they make sense. If you have a systolic blood pressure less than 90, having an increased risk of 26% of having an intra-abdominal injury, that really tracks. What's amazing is just abdominal tenderness increases the risk by 5%. And I don't know if it's because there was little abdominal tenderness in the population, or there was so much abdominal tenderness that only some of them had actually clinically significant injury. Hematuria, 24%, and you can see all these confidence intervals they do not straddle the index, so they're all statistically significant. But as you can see, the numbers do look a little bit more impressive with relative risk. Not the big numbers. 26% versus increases it by 4 times, that doesn't sound as impressive. But yeah, okay. So if anybody has any questions, if you are taking the course for credit, don't forget to take the quiz included in the show notes, and you can email me questions. If you're just perusing, by all means, put some comments down below, and thanks for watching.